Hi, I'm Haocong. I'll be presenting our work RowPress, Amplifying Read-Disturbance in Modern DRAM Chips. In this work, we demonstrate and analyze RowPress, a new read-disturbance phenomenon that causes bit flips in real DRAM chips. We show that RowPress is different from RowHammer, demonstrate it in a real system with a user-level program, and provide effective solutions. So, what is RowPress? RowPress is the read disturbance caused by keeping a DRAM row open for a long time, which induces bit flips in adjacent rows. These bit flips do not require manual activations, and we find in some cases only one activation is enough. Now, let's see how this is different from RowHammer. Read disturbance has significant system-level implications because it breaks memory isolation. A prominent example of this is RowHammer, where repeatedly activating and closing a DRAM row many times causes RowHammer bit flips in adjacent rows. RowHammer is the only studied read disturb effect, and various mitigations work by detecting high row activation count. This raises the following question. What if there's another read disturb phenomenon that does not rely on high row activation count? Instead of high activation count, RowPress increases the time that the aggressor row stays open. Doing so disturbs adjacent rows enough to cause bit flips without a very high activation count. We even observe bit flips with only one activation in extreme cases. We use an FPGA-based DDR4 testing infrastructure to characterize RowPress using DDR4 chips from all three major DRAM manufacturers. Our characterization yields the following two key takeaways. First, RowPress significantly amplifies DRAM's vulnerability to read disturbance, and second, it has a different mechanism compared to RowHammer. RowPress amplifies read disturbance because, first, it reduces the minimum number of row activations needed to induce a bit flip by 1 to 2 orders of magnitude. Second, in extreme cases, activating a row only once induces bit flips. Third, it gets worse as temperature increases. RowPress is different from RowHammer because it affects a different set of cells and behaves differently as access pattern and temperature changes. We demonstrate RowPress on a real system with a recent Intel processor and a Samsung DDR4 module with TR RowHammer mitigation. The key idea is to keep a DRAM row open for a longer period by keeping on accessing different cache blocks in the row. Our results show that leveraging RowPress, a user-level program induces bit flips when RowHammer cannot. We propose a methodology to adapt existing RowHammer mitigations to also mitigate RowPress. The key mechanisms are, first, limit the maximum time that a row can stay open, and second, configure the RowHammer mitigation to account for the RowPress-induced reduction in the number of activations needed to cause bit flips. Our solutions mitigate RowPress at low additional performance overhead. We have more results in the paper, and our work is fully open source and artifact evaluated. Thank you for your attention, and I invite you to our full talk and read our paper for more details.